going to look here at solving quadratic equations. Solving is where we find the value of an unknown by rearranging an equation, and an equation is quadratic if there's a variable squared somewhere in the equation. Generally, we're going to get two solutions for quadratics, both of which we need to give as our answer. Layout is the same as always, has to be correctly done down the page, one step at a time. And of course, each step leaves us with an equation. And the steps we do, what we do on one side, we must do on the other to keep everything balanced. If we multiply, divide, square, or anything like that, it must be done to all of both sides. And particularly with respect to quadratics, we need to avoid squared unknowns that are negative, because then we can't factorize them. And the order of steps to solve quadratic equations: we remove any fractions by multiplying both sides, all of both sides, by the denominator. We expand any brackets unless it is already fully factorized as a quadratic. Assuming at this point that we have a quadratic after we've removed denominators and brackets, group all the terms on one side of the equation and make them equal to 0. This is the opposite of linear solving, where we separate the unknowns from the numbers. With quadratics, we must group them all to one side. We simplify, we factorize, we solve the first bracket by making it equal to 0, we solve the second bracket by making it equal to 0, and then we give both our answers. The key concept: the whole thing depends on understanding that if we multiply two numbers together to equal 0, then one of them must be 0. If a times b is 0, then either a is 0 or b is 0. And quadratic uses that procedure. We have two numbers, admittedly they're numbers in brackets, but x plus a is a number and x plus b is a number when we put in the value of x. And if those together equal to 0, then either the first bracket or the second bracket must equal 0. For the first bracket to equal 0, then x is minus a. For the second one, x is minus b. Because if x is minus a, then the first bracket, x plus a, turns into minus a plus a, which is 0. So 0 times the second bracket, which is 0. And the same procedure occurs for the second one. If x is minus b, then the second bracket becomes minus b plus b, which is equal to 0, and we have 0 times another number is 0. That's what we have to remember. If we have factorized quadratic equal to 0, then the solutions are the negative of the two factors. So we need to head in that direction when we solve a quadratic. We need to get to the form a quadratic is equal to 0. Here's a very straightforward example. It's already factorized. We don't need to expand it. We have a quadratic is equal to 0. We merely set out each of the two brackets is equal to 0, which gives us either that x is minus 4, which that makes that bracket equal to 0, or x is 8, which makes that one, and that's our answer. Very simple. We just need to recognize the situation. Here's another very similar one. Again, either the first bracket or the second bracket is equal to 0. So the answer is either 0.75 or minus 5, which is what we indicate. However, if you're not very good at working out this value here, the fraction value, then you do a simple linear solve. You know that 4x minus 3 is equal to 0, so 4x is equal to 3, divide by 4, and x is equal to 3/4, 0.75, doesn't matter which one. Slightly harder this time, we see we have a quadratic equal to 0. So when that happens, we factorize, we set the first bracket equal to 0, second bracket equal to 0, gives us two solutions. This time we have the quadratic, but it's spread across the equal sign. We know it's a quadratic because it has an x squared, so we need to get everything onto the side with the x squared. It's very important that we move the 6x minus 5 to the right because we need a positive x squared when we come to factorising. So we do that, and we have all on one side, positive x squared. A quadratic is equal to 0. We can factorise that. We set the first one in the second bracket equal to 0, and we get our two solutions. As it gets a bit harder now. Firstly, just because we have a factorised quadratic doesn't mean we're finished. In this case, sure, we've got factorised quadratic, but it's not equal to 0, it's equal to 3. We cannot solve in that situation. We need a quadratic is equal to 0. So, we expand out the brackets, move the 3 across. Now we have quadratic equal to 0. We can factorise, set the brackets equal to 0, get our two solutions. It's not always immediately obvious that you have a quadratic before you start. This might look like a linear equation, but the first step is to remove the denominator of the fraction, which we do by multiplying through both sides, all of both sides, by all of the bottom. So it must be bracketed. When we cancel out the left hand side and expand the brackets, we see that in fact we have a quadratic equation after all. There's an x squared. We need to move everything to the right because we need a positive x squared. Do that. We have a quadratic equal to 0. We factorise. We have our two solutions. Sometimes, not normally at achieved or merit, there's a little twist, which is that although we definitely have a quadratic because we have an x squared, once we move it all equal to 0, we have an issue because we have a multiplier of 3 out in front. When that happens, we just take the 3 and we divide it out of each component, the 3, the 21, 30, and that leaves us a quadratic which we can factorise. Now at this point, any one of those three things, the 3, the x minus 5, or the x minus 2 is equal to 0, but 3 can't equal 0, so x is the opposite of in the brackets, and we have our two solutions. So, things to look out for. We have to watch that we have a quadratic equal to 0, or we can't start. There's a little bit more to it sometimes than that. Here we have a fairly simple equation. We expand the brackets out, that's our first step. We gather everything on one side, except when we subtract the two x's, it looks like we've got a very simple equation, and we're very tempted to make x is equal to 4. However, we must resist doing this. Every time we have a quadratic, we must group onto the left hand side, factorise, set the two brackets equal to 0, because there are in fact two solutions to an equation like this. If we have a quadratic, we expect there to be two solutions. Don't just rush off and square root it, because you need to have plus or minus the square root. There's one time it won't have two solutions, and that's when we have an occasion like this, which when we factorise, we get the same factors. So we have two solutions, but they're the same solution. What we do then is it's a square and we only have one solution. That's the only time a quadratic won't have those two solutions. It's when it's the same solution repeated. So here's our key concept. We factorise a quadratic, make it equal to 0, then the unknown is the opposite of what's in the brackets, and there will be two answers. And the procedure to get there: multiply through by any denominators to remove fractions, expand brackets unless it's already a fully factorised quadratic equal to 0. Then, assuming there's an x squared term, we group all the terms on one side of the equation equal to 0 so that x squared is positive. We simplify, we factorise, and then we solve the first and the second bracket to give both answers.